So these notes are on probability, using area models, area model and tree diagram. And expected value. We'll do them all. Okay, so first one is going to be an area model example. Let's say we have 2 bags with colored marbles. The first bag has 3 red, 2 yellow, 1 green. The second bag, let me just get this a little bigger. Oops, wrong direction. The second bag has 2 red, 4 yellow, and 3 green. You pick 1 marble from each bag. And if you get the same color from both bags, you win. So let's first do our area model, and then we'll figure out what the probability of winning is. So I have 3 different colors in each bag, and I have 2 different bags, so I'm going to do a 3 by 3. Let me zoom out a little bit. Okay. So let's say that we have let's say I've got red, yellow, green, and then red, yellow, green. Let's say that this is bag 1. So I have, in this bag, I have 3, plus 2 is 5, plus 1 is 6. I have 6 total. So red, I have 3 out of 6, or 1/2. Yellow, I have 2 out of 6, or 1/3. And green, I have 1 out of 6. And going the other bag, I've got 2 red. So I've got 2, 4, so that's 6, 9. So I've got 2 out of 9 that are red. I have 4 out of 9 that are yellow, and I have 3 out of 9 that are green. And then I can multiply these together. So it's going to be 6 out of 54. This one's going to be 4 out of 54. I get 2 out of 54. Now I'm going to multiply 4/9, so I'm going to get 12 out of 54. I'm going to get 8 out of 54. I'm going to get 4 out of 54. For the next one, I'm going to multiply by 3/9, so I'm going to get 9 out of 54. I'm going to have 6 out of 54, and I'm going to have 3 out of 54. So just a quick little reminder that if I add 3 6 plus 2 6 plus 1 6, I get 6 6, which is a whole. So I should be getting 1 when I add this way. I also have 2 9ths plus 4 9ths plus 3 9ths. That adds up to 9 9ths, which also adds to a whole. So this has to add to 1. This has to add to 1. Now, I didn't reduce this. I kept everything as 54s. So 6 plus 4 plus 2 plus 12 plus 8 plus 4 plus 9 plus 6 plus 3. I should be getting 54 54s, and I do. So that adds up to a whole. So you want to make sure that is true. So let's say for the first question, I asked, what is the probability of winning? And so the probability of winning is getting the same color twice. Okay, so what is the probability of winning? So this would be red and red. This would be yellow and yellow. This would be green and green. So I'm going to be taking 6 54ths plus 8 54ths plus 3 54ths. So I end up with 17 54ths. Okay, that's the probability of winning. And just to kind of see the value of that, 17 54ths would be about 31.5% chance. Now, if they ask me what's the probability of not winning, I don't have to go through and add up all the ones that were not winning. I know that my winning plus my not winning needs to add up to 100%. So what I'm going to do is I'm going to use what we call the complement. I'm going to take 1 minus 17 over 54, or basically 54 54ths minus 17 54ths. So 54 minus 17 is 37. So it's going to end up being 37 54ths chance of not winning. Now, if they ask us if this is a fair game, is this a fair game? It's a fair game if the probability of winning and losing is the same. Okay, so you have half of a chance of winning and you have half of a chance of losing. So is this a fair game? No, since not equal probability. So no, since the probability of winning does not equal the probability of losing. Okay, the next example I'm going to do is going to be an area model, okay, and I'm going to do one of the basketball problems, okay. We'll say that this time the player has an 85% chance of getting their free throw in. So let me write that out for you guys. So let's say we have a one and one situation. So again, that means if they get their first one in, they get to take a second second shot. If they don't get the first one in, they don't get a second shot. And let's say a player has an 85% free throw average. And let's say, what is the player's expected value? Okay, and I'll put in parentheses expected point total. Okay, so for this one, we're going to do a tree diagram. Okay. So this is the first throw. They're either going to make it in or out. They have a 0.85 chance of making it in, which means they have a 0.15 chance of making it out. If they make it in, they get to take another shot. And again, they have a 0.85 chance of making it in, and they have a 0.15 chance of making it out. If they did not make it in the first time, they're done. So now we're going to work out the probabilities. This one here is going to be probability of 2 points. And so we are going to take 0.85 times 0.85. So 0.85 times 0.85. And we end up with 0.7225. 0.7225. Probability of 1 point. Okay, I'm going to take the probability of getting in times the probability of getting out. So that's going to be 0.85 times 0.15, which is 0.1275. 0.1275. And then this one is the probability of 0 points, which is 0.15. Now, again, notice that these two branches add up to 1 or 100%, 1 or 100%. And if I add up all three of these, 0.7225, 0.1275, and 0.15, I should be getting 1, and I do. Okay, so that's always a way to double check yourself. So again, this is the probability of getting 2 points. This is the probability of getting 1 point. This is the probability of getting 0 points. So they're most likely to get 2 points. Okay, they have 50% chance or 0.15 probability of getting no points at all. But if they're asking for expected value, so expected value, take probability times the amount 1 and add up all situations, okay, or all outcomes. So what I mean by that is the following. So I'm going to take 0.7225, which is the probability of getting 2 points, times the amount of points that you get, plus 0.1275, which is the probability of getting 1 point, times how many points you get, plus 0.15 times how many points you get. And we're going to add this up. So let me do this on the calculator. I'm going to push this up a little bit. So 0.7225 times 2 plus 0.1275 times 1, which I don't need to do, but I'm just trying to show you the math, plus 0.15 times 0, again, don't need to do it, but just showing you the math. And you end up with 1.5725. So 1.5725, that is the expected value. Now remember, expected value, it does not need to be an outcome that will really happen. The player will not be able to score 1.5725 points. They're either going to score 2, 1, or 0. But on average, over time, this would be the average amount of points. And that's your notes for today.